Next is grading. So I think I can get rid of that. I'm going to keep stellarium, bring that down. Now let's see, I'll show you, so there are a couple things. One thing is we have this grading guide. And after we get the video put on YouTube and I send that around, I'll send a link to this grading guide. You don't have to use my grading guide. You can go in and change how much different things are worth in WebAssign. But as once you sign up and you get it, it has kind of a default number of points. And this grading guide is suggestion, because I have many different TAs. They're all young. They maybe have never taught before or graded before. There could be wide variation in how they do the grading. So I try to create a little bit of uniformity here. So it's suggestions. That said, many things are auto-graded, which is great. It allows this to scale to very large classrooms. But some things can't be auto-graded, like short essays or the plots. Did they do their plot correctly? Maybe you want to check their moon identifications, things like that. So I have little tips in here of how I instruct my TAs to assign the points. And I'll go through this now to give you an example. But again, you don't have to use this. Most people find it very helpful. And particularly if you haven't graded for a year and you're trying to get back into it, and this quickly reminds you, oh yeah, this is how I can go about doing this efficiently. So it's just a Google Doc and that'll be made available to you. Now let's see. I can't violate FERPA. So what I want to do is I want to open up one of these and we'll look at it, but if it's a student, that's FERPA violation. But what I do have, I have a forced certificate version of this course that we just run. There are no due dates. People just do it at their own pace. And they're not official students or anything. It's just a public program. So I can go in there. So let me go down here, be at the bottom because it's been there for years. And we can expose one of them. I went down to my for certificate section, Lab 1 scores. Okay. And those are those alphanumerical things that I was mentioning. I've chosen this student here. He's the one that we're going to look at. But you go to grade answers, and we're picking the second question because that's where all the scoreable parts are for this particular lab. Start grading it. It dumps you off on the first student. And so now you can see what they submitted. Now this first student didn't do anything. In the for certificate course, a lot of people sign up but don't actually do it. So I'm going to hop down to the student that we selected, Craig Bowers. It's loading up his work. Okay. And so we're in answer key mode, but you can also see their answers now. So in the first part here, this is where they were imaging the planets and then zooming in and changing the brightness and contrast to make it nicely observable. And then you can add, or you can click on the link to see what they submit. So that's not bad. I would have zoomed in a little bit more, but good picture of Venus and its phases. Mars, let's see how he did here. Oh, that's really nice. That's a good one. Again, I would zoom in to fill the whole thing, but I wouldn't penalize him for this. You can see the ice cap there. He also got Jupiter. Again, really crisp, but I would have zoomed in. Maybe let's look at one more. Saturn, okay? Now the grading guide, I guess you didn't see it because I wasn't sharing, but again, it's this Google Doc, and all the different labs are tabs here, and it just lists the things that you have to grade, the parts that are not auto-graded. Then section PB1, those are these first set of images. It says I'm going to give up to 3 points per detected object. There's a little note there that Mercury, they probably aren't going to get Mercury. It's almost always too close to the sun to observe. And then little notes like subtract a point if they forgot to zoom in, like if it's this big black field with a tiny dot at the center, that's not very useful. They should have zoomed in. They needed to set the contrast to min-max so you can see the detail on the planet. Otherwise, you'll just see the sky glow. Subtract a point if it's streaked because they could have resubmitted. And I also point out some students may pull out an extra object or two, maybe out of twilight, or they adjusted their settings so they were able to get an extra object or two. And how you treat that's up to you. If they did the extra work to pull out an extra object, I give them points for that as well. And then in the lab, the next thing they were asked to do is to write up a description of the detail that they see in their observations. This student did a very good job. In fact, I've never seen this much. He's written a detailed paragraph for each object. I'm really just looking for a sentence or two in the answer key. You can see how I would have answered the questions much more tersely. But so this looks really good. And I basically give them a point. No, it's 3 points per object and to use the key. Then the next thing's in section PB2. That's this table down here. And this is where they're saying which objects they actually got an observation on, what telescope they used, the system date and time, and they measured the angular diameter. This is stuff we went over a couple of weeks ago. And so what the grading guide suggests is 10 points total, 5 points if they fill in the telescope and date and time fields for the observable objects, and then 5 points if they got all the angular sizes in the acceptable range. And so you can see here, this particular student got check marks for all the measured sizes. And all this is doing is it takes an object like Jupiter. He measured 30 arc seconds, and it's actually not checking at this particular time. It just is checking, is this between the smallest Jupiter ever gets and the biggest Jupiter ever gets. And there are buffers built on for atmospheric blurring. It's a very, very generous check. And then I see he got 6 out of 6 check marks, so I give him 5 points for that and 5 points for filling in that information, and I type that in here. And this is the part where they were signing their name. They thought it was some kind of honor pledge, but really I just have that in there to give you a place to do the scores. Now, in many of the other labs, the tables will grade, not just put up check marks, but actually do the scores all by themselves. I don't in this lab because I never know what objects are observable. It changes from semester to semester, and institution to institution. You may be doing the labs at different times in the semester. So that part, it does check automatically, but assigning the score, I leave that to you manually for this case. Because they could then cheat the system by saying I observed everything when not everything was observable. Okay, and question.
Do you ever have students who do that, who say they observed an object that's not currently observable?
Sure. I mean, we have 500 students a semester at UNC, so you see everything that you can imagine seeing.
Do you deduct for that?
As we have it set up, the TAs do the grading, and I don't have a contingency for that. I mean, technically that's lying. That could be an honor code violation. Right now we just give them 0 for that. Or maybe they grabbed an image off the sample directory. I don't see that hardly at all. And the ones where it can be a serious offense, I will write demo on the image in the sample directory. Now, one thing I do see is sometimes a student will start and drop out and come back the next semester and use their images from the previous semester, and that's fine by me.
Mm-hmm. Cool.
And we may have the TA give them a talking to, saying, don't try a stunt like that again. The next table here, this is where they look up the true diameter in stellarium and calculate a percent error. So again, this student, I picked one with a high score, so clearly a good student. Got all these right, though he did do one miscalculation. This percent error is miscalculated. Before we started, I looked up a student who wasn't as good to give you an example of something else. So here's one from another student. Got some things right, but mismeasured Ceres, mismeasured Jupiter. And so you can see stellarium will give you an X and say it's too high or too low. And then there's this thing called the calculator. Calculator errors, this is something in WebAssign where it means they did the calculation correctly, but based upon inputs that were wrong. And so that's a nice thing to have, except WebAssign counts that as no points. And I would count that as full credit. and other people would count it as something in between. And I've been talking with WebAssign to try to get them to give us that flexibility. And if they did the calculation right, I've already penalized them for measuring it incorrectly. So I don't want to penalize them again for the calculation. At least they do mark that as a separate thing, so you can treat that as you want. Now for this part here, since we don't know if all the planets are observable, again, you're counting up check marks and distributing the points. Like this is worth 10 points. So I figure out what fraction of these were check marks or calculators, because I count the calculators, and then that fraction of 10 points is what I assign. But in other labs, where it's just fully auto-grading, if they get a calculator, they'll get no points for that. And so I have my TAs go through, and if they're calculators, they can add the points back in. All the labs have little sections like this where they've signed their name, so a place for you to add points, and you can just add them in there if you want. Hopefully WebAssign will give us more flexibility in the future, but I've been trying to get them to do that for some time. Other things, like here's a place where they're doing a % error sample calculation, and in the grading guide, I give my TAs different things that would be acceptable and things that are not. So like sometimes they forget their parentheses, and so they'll miscalculate for that reason, so they could lose a point there. Sometimes they forget to multiply by 100. Sometimes they forget the absolute value, and so they come up with a negative % error. And so those are things that I might subtract a point out of the 3 points for. I never keep subtracting things and give them negative points for something. If they've lost all their points through a comedy of errors, I don't go negative. I stop at 0. And sources of error. This one, if you remember, was a discussion about atmospheric blurring. And the grading guide says give them a point if they mention atmospheric blurring. Give them a point if they can describe why the % error is big on the small objects and small on the big objects, because atmospheric blurring is a small fraction of Jupiter, but it's a huge, it's much bigger than the size of Ceres. And so you get that trend that the small objects have bigger % errors. And then the third thing I say, give them a point for here, this last source of error. It's hard to identify the edge of the object. It's some level of grayscale. It's pixelated. So again, these are just recommendations, but that way you don't have to think through it from scratch. It's a starting point. Moon identification. Some people don't bother to check. I have my TAs check. So let's do one of these here. The students, let's do the tough one, Uranus here. So you can click here. What I have below here is kind of the sample. This is what the student actually submitted. So here's Uranus. The student adjusted the brightness and contrast to pull out a few extra moons close to Uranus that would have been lost in sky glow, and has identified them as such. Now what I like to do is I just have Stellarium open in the other window, or the other screen. Lock these in here and maybe go back to normal viewing. And since these images can be taken from all over the world, I don't like messing around with changing the location. I'll just hide the ground and I'll hide the sun, so it's night everywhere. And I'm going to type in Uranus, and it's going to take me there. But also I have to get the date and time correct. So this student did this observation in 2018, September 5th. Hard time here. There we go, September 5th, 1334. So then we'll zoom into Uranus here. And you may remember from before, there's this little telescope symbol that will put in equatorial coordinates. So that will make the image match up with their image, though there could be a flip. Always keep that in mind, there could be a flip, and you may have to do that mentally. And so they said Titania, Ariel, Umbriel, Oberon, and so they got that right. Now if you look at this carefully, it doesn't match up exactly. I think they got all the moons right, but kind of the positioning, it's a little bit skewed. These are a little bit more off to the right. Oberon's a little bit lower. And probably what's going on here is this user, for certificate program, I have users all over the world. This user is probably based in Europe. So I may have to adjust the time here. And if I subtract off 4 or 5 hours, then it looks a lot closer to the positioning. Maybe I went the wrong way. Maybe they're not Europe, maybe they're subtracted off time. Anyway, when I rewrite the lab, I'm going to do this in universal time. It's all in system time because originally Stellarium would only give you system time. They didn't give you the universal. And now it gives you that option. So I'm probably going to swap it over to something more concrete. But anyway, if it doesn't quite match up, just fiddle by a few hours and it'll probably be fine for now. So in that case, according to the guide, I would give them, let's see what I recommend. For the image, I give them 3 points, kind of for the standard stuff. Did they zoom in? Did they put the brightness and contrast on Z scale, blurring out the planet, but so you can see the moons? Did they adjust it so they can see the moons? And then under moon identifications, I subtract points if they got some of the IDs incorrect. And things of the, let's see, use Stellarium to identify, subtract a point if they incorrectly ID'd, subtract a point if they missed a moon, 0 points if the date and time are wrong. If they put in some date and time and you cannot replicate their image, then I wouldn't give them credit for that. But again, you can treat that as you want to. And some people don't grade this, they just let it be. It is a little bit time consuming, but if you have a second monitor and you have Stellarium over in the second monitor, you can zip through these really quickly. And again, I'm not going to do this for every lab. I'm just doing this in detail for this one lab. Down here, there's a part where it asks you to ask the student to just look up each of the moons and write down a fact, so just a simple sentence. And as long as they have a fact for each of the moons that were actually there, I give them credit for it. The last 2 parts of the lab, one is moon identification, one is the deep sky objects. So under moon identification, let's see how this student did. They did Pluto. So there are 2 images that they're submitting. There's their image and the DSS image. And the grading guide says 1 point for the correct field, 1 point for marked reference stars, 1 point for marked and plausible dwarf planet ID. I'm not too hard of a grader because these are hard to do, particularly with the online students where they have less of an opportunity to ask for help. So this is the image they got. They think this one here is Pluto. They didn't mark any reference stars, so they would lose a point for that. That means it's more work for us as the grader to figure out, is this actually right? Here's the DSS image. And if I blink between them, at least I already can do the alignment because I'm good at this. And yeah, the object they marked is not in the DSS image. But really what they should have done is marked the same reference images in both and zoomed into this region to make it really easy for the grader. Then yeah, I see stars A, B, C, and D that they marked in both images. And yeah, there's this extra thing here they labeled Pluto that's in the one that's not in the other. The only downside here with WebAssign is they only let you view one at a time. So sometimes I have to do a screen capture and put it to the side and load up the other one. And then the question? Okay, the final part is just we had them pick a nebula, image it in just the brightness and contrast until it looked good. A globular cluster, that looks good. And a galaxy, looks good. So for those, it's pretty straightforward. As long as they did it, they get 2 points. And then they're gonna look up a fact about each. Again, each one is worth a point. So that's an example of how to grade lab 1. My experience with grading is it gets easier from lab to lab to lab. Now, Lab 1, remember, is not very scientific. They're learning how to use Skynet, how to use Afterglow. It's an exploration, and not all the targets are always visible, which puts a little bit more burden on you as the grader. But as you go from lab to lab, the more of it can be auto-graded, the easier it gets, as we'll see. Anyway, I'm not going to go through the grading of all the other labs. I just want to give you an example of that. So questions about grading before I show you some Afterglow 2.0. I think it's a pretty nice grading interface that they built, except for that issue with the calculators. And of course, if we go back to this screen here, there are lots of opportunities to go in and override a grade, add bonus points, things of that nature that we often have to do as a matter of course based on circumstances.